Look out at the sky today and you are observing a fragile statistical anomaly. We call our current geologic epoch the Holocene, and while it feels like a permanent planetary baseline, this specific atmospheric balance is highly irregular. This graphic demonstrates the scale of that irregularity. If we compress the Earth's 4.5 billion year history into a single 24-hour cycle, the exact conditions required to support human life do not account for a day, an hour, or even a minute. They occupy only the final 3 seconds. To accurately measure the lethality of historical environments, we can apply a specific diagnostic tool, testing the absolute limits of human physiology against the failure points of modern extravehicular activity spacesuits. Our baseline metrics for survival are strict. We require an atmospheric pressure of 1 atmosphere, an oxygen concentration of 21%, and a global average temperature near 15 degrees Celsius. Deviate from this telemetry, and we introduce immediate failure vectors, severe thermodynamic extremes, toxic chemical overrides, and massive kinetic events. Understanding planetary habitability requires abandoning the assumption that Earth is naturally hospitable. We have to quantitatively analyze the exact geological and atmospheric mechanisms that made this planet's past a lethal environment. 4.5 billion years ago, during the Hadean Eon, the Earth was entirely molten. A human observer introduced to this environment would experience immediate thermodynamic shock. The atmosphere here is a dense supercritical fluid composed of carbon dioxide and vaporized silicate rock. This diagram compares the atmospheric density of the Hadean Eon to modern pressure constraints. Standing on the early Earth, the atmospheric pressure is 100 times greater than today. The physical force exerted is equivalent to being crushed under 1.6 kilometers of ocean water. The physical stress is compounded by orbital mechanics. At the dawn of the solar system, the newly formed moon was orbiting 15 times closer to the Earth than it does right now. That proximity generated immense gravitational friction. The moon's pull literally dragged the molten rock, raising continuous, kilometer-high displacement waves of magma. Under these parameters, the failure mode is instantaneous. The shear pressure crushes the composite armor of an EVA suit before touching the surface, and the 2,000-degree ambient heat vaporizes organic remains in less than 0.05 seconds. Earth's initial physical state was an active thermodynamic incinerator. The conditions of planetary birth are incompatible with biological structures. By 2.4 billion years ago, the magma oceans had solidified, but the environment simply shifted to a different thermodynamic extreme. This visualization shows the oxygen catastrophe. Oceanic cyanobacteria produced oxygen. As this reactive element flooded the atmosphere, it dismantled the methane structures, providing a greenhouse blanket. Without methane, severe glaciation locked the planet in ice, dropping average temperatures to minus 70 degrees Celsius. Thermal exposure is only one vector here. Earth had not yet formed an ozone layer, meaning raw, unmitigated ultraviolet radiation directly bombarded the surface, degrading protective materials and biological tissue. Skip forward to the Cryogenian period, 700 million years ago, known as Snowball Earth. The oceans froze to the seafloor, and atmospheric circulation stalled entirely, leaving a geologically inert environment. The physiological failure mode in this era is driven by extreme convective heat loss. Dense, icy winds pull heat away from an EVA suit much faster than the vacuum of space, draining batteries and inducing hypoxia and fatal hypothermia within 10 minutes. Biological innovation, oxygen production, acted as a devastating planetary weapon, converting the entire globe into a sterile cryogenic tomb. 300 million years ago, the Carboniferous period presented a completely different chemical threat, a hyperoxygenated atmosphere peaking at a 35% concentration. That specific oxygen density allowed for radical biomechanical scaling. The dense atmosphere enabled insects like millipedes to grow over 8 feet long. But a 35% oxygen mix makes combustion physics highly volatile. Even living, wet biomass ignites easily, turning ordinary lightning strikes into massive, fast-moving firestorms. Moving forward to the Carnian pluvial event, 232 million years ago, the threat transitions to moisture. Earth endured a continuous precipitation event lasting for 2 million years. The geological trigger was widespread volcanism. Deep fissures injected gigatons of carbon dioxide into the atmosphere, inducing an extreme hyper-greenhouse effect that rapidly evaporated the oceans. The environmental parameters trap a human observer in a lethal equilibrium, a constant ambient temperature of 40 degrees Celsius paired with 100% relative humidity. This graph illustrates the physiological limit known as the wet bulb temperature. When humidity hits 100%, sweat completely fails to evaporate from the skin, neutralizing the body's only mechanism for thermoregulation. The failure mode here is biological overheating. Unable to shed heat into the saturated air, the body's core temperature climbs until it cooks, resulting in fatal hyperthermia and cardiac arrest in under 12 hours. Periods of lush biological abundance on Earth were often driven by runaway chemical extremes. These exact conditions would quickly overwhelm modern mammalian physiology. 66 million years ago, the Chicxulub asteroid impact demonstrated the mechanics of planetary-scale kinetic energy transfer. This animation tracks the two distinct waveforms radiating from the impact zone. A 100 million megaton seismic wave travels faster through the solid crust than the acoustic shock wave travels through the air. The physical force of that seismic wave arrives first. The sheer kinetic energy ripples through the ground, causing immediate structural failure by shattering the bones of local biomechanics before the heat hits. Internal pressure releases carry similar force. 74,000 years ago, the Toba supervolcano erupted, blowing out a massive geographical caldera. Toba injected massive volumes of sulfur dioxide directly into the stratosphere. The particles blocked incoming sunlight, halted photosynthesis globally, and crashed the planet's temperature. The eruption initiated a severe volcanic winter. Gray ash fell in place of snow, triggering widespread ecological collapse and massive starvation. This diagram models the genetic bottleneck effect that followed. The extreme paleoclimate forced early human populations through a tight survival funnel, leaving an estimated global population of only 2,000 individuals. Homo sapiens were highly vulnerable to these conditions, whereas Homo neanderthalensis possessed specific biomechanical advantages built precisely for the deep freeze. Neanderthals featured a distinctly lower surface area to volume ratio. Their wider, barrel-shaped chests and shorter limbs functioned as a highly efficient thermal retention system. Surviving these harsh climatic phases was a narrow statistical anomaly. Our species was nearly erased by the raw mechanics of volcanism and kinetic force. Having established the failure limits of Earth's paleoclimates, we can apply those exact physiological stress tests to the rest of the solar system. We use deep space probes as proxies for human observers. They're heavily shielded instruments built to withstand conditions that instantly destroy organic life. The supercritical pressure and intense heat of Earth's infant Hadean eon exist today as the baseline reality on the surface of Venus. Landing a human on Venus today triggers the exact same failure mode experienced on early Earth, immediate structural crush from 90 atmospheres of pressure. Similarly, the extreme convective freezing and oxygen-depleted environment of the cryogenian snowball Earth perfectly maps to Saturn's largest moon, Titan. Titan features active lakes of liquid methane. It demonstrates the absolute chemical stagnation and sub-zero extremes of Earth's deep cryogenic past. Unmitigated ultraviolet bombardment before Earth's ozone layer formed is negligible compared to Jupiter, where the magnetic radiation belts are 18,000 times stronger than Earth's. The deadly failure vectors that were temporary phases in Earth's paleoclimate are the permanent realities across the rest of the solar system. Biological habitability is not an inherent geological trait of any planet. It is a highly transient chemical and thermodynamic equilibrium. Our Holocene epoch represents a brief, incredibly fragile window of survival within a relentlessly hostile universe.